Friday. 9 weeks done. 7 weeks, but in this class I think it's like 5 or 6, because of the 2 Fridays we'll miss, Thanksgiving and the end of the term. Learning. In the curriculum we have a teacher's perspective, so students can complete that. We'll talk about that on Friday. We talked about network services, client server, and we did a packet tracer, an experiment with a packet tracer. Alright. Clients, we talked about all these possibilities for clients. We have these devices that communicate with some server. Believe it or not, a lot of communications are that way. And let's just talk about that. Information. A good example, even though information, data being converted into information, it's pretty common what software and computing does. But we used one example, web server, communications, and we have a couple protocols. Hypertext Transfer Protocol, port 80, Hypertext Transfer Protocol Secure, port 443. We talked a little bit about you can have in your client, like your, let's just say a PC or a laptop, you have all this communications going through it, and you say, well, what do you mean, all this communications? Well, you could be reading your email, you could be downloading a file from the web, and those could be going on at the same time. You could even be logged into another server, and all of that traffic through your computer can be managed through port numbers. Talk a little more about that next week. So, some of these services we talk about. Email. We have email servers. Software and apps. We can download these files or programs to our computer. Doing basic communications, whether that's email be one, but then we have all those other ones. Snapchat, WhatsApp, Instagram. We have a lot of different ways that we can communicate on a client-server situation. Software on servers that allow us to do that. So we talk about some ways in which it works, like for example, a web server uses a uniform resource locator. We have a domain name, and it gets converted to an IP address using a protocol called DNS, which is port 53. You can register a domain name, and we looked at some examples. Then we kind of looked at this big picture. For example, we did a situation like you might be at home and you might use your Google account to send some email to somebody on Yahoo. So if we were to think a little bit about that, so you communicate to this, your account here, and then that communicates to here using simple mail transfer protocol. Then the mail is sitting here. Let's use a different color for that. Let's say your mail here is in blue. And then you're at the coffee shop. I'll use another color. And then you take the mail and bring it to your computer sitting at the coffee shop. That's POP, Post Office Protocol, where you grab the mail off the server. And then one thing we mentioned here, that mail is constantly being backed up. So even if the mail is deleted, it still could exist in a backup. And that's true of anything connected to the internet. Anything. You know, what you have stored in your Facebook account or anywhere, you can say, whoa, I didn't mean to have that there, and you can delete it. But it could very well already be stored somewhere in a backup, which you can't erase. you can't go in and erase all that stuff. Okay. And to function through the internet, we use domain names that are converted to IP addresses with domain name services. Oh, we also talked about, students talked a little bit about security. You can set up a service for relatively small amount of money, less than $10 a month, sometimes as low as 5 or 4, with a service, so that, let's say you're on your phone at having coffee, and you don't want anybody to be able to see any of your information that's being sent. So what happens, I'll just use yellow here, there's some software on there that's going to encrypt the information, which then allows you to send it to here, and then they will send it out to whatever location you're going to. And it'll be encrypted. Does that make sense? Yeah, you can, and in these, this is a client-server scenario, and these virtual private network, that's what those letters stand for. These, they have servers all over the country. And so you can communicate through them almost pretty much from anywhere as you get connected to the internet. So if you're here at NIAC and you don't want NIAC, so to speak, to see your communications, because it has to go through their equipment and it's got to go through the ISP. You can't stop that from happening. So if you don't want to see it, you can then, let's just say, using this red, you can encrypt it here before it leaves to here and then back in. And there's lots of other services besides Nord VPNs. Almost done. We did another example of client server. We used PuTTY and use SSH port 22. This is secured shell. That's what the SSH stands for, secured shell. And I used my last name, first initial, it's the caps and a caps. It worked the same way for the students. This is the password preset. And you can connect then to this server. So you're the client. And then you connect to this, and it's a Linux server. And then you can do work on that server. Various things you can do. We'll talk a little bit more about that later on. But on that Linux server is a web server, Apache, that then we can manage websites. Pretty simple scenario, okay? So this is the internal private address that works for that server. This is the external public address that works for that server. Now, one more thing, this was secured shell. There is a way to connect to servers, and typically that's not done anymore, except in some situations. You can telnet to a server, and that's port 23, but that's not secured. For example, file transfer protocol, you can send files between like a client and a server, but nothing's encrypted. Or you can use secure copy. Then you can send a file between two locations and it's encrypted. We're going to talk a little bit more about security each week. Encryption is you redesign, you move the information around so you can't read it, and then you can encrypt and decrypt like a message. That's it.